Now, so let's take a look at problem number 2 from Excel module number 3. So for problem 2, you're given 3 sets of equations. So if you remember hopefully you remember from your math, right? When you're solving for multiple unknowns, you need to have at least the same number of equations as unknowns. So in the first case, we're solving for, and you can see I've cut and pasted a picture of the original problem. Right, we've got 3 equations, 3 unknowns, x1, x2, x3, and you need to solve for those unknowns. So you can see on my spreadsheet, right, I've got my headers, as you should have on each page. And the process, and again, there's essentially 2 ways you can solve these problems, right? So hopefully you remember this from when you're doing math, right? You can do substitution. So you can solve for one of the variables, plug it into another equation, and do substitution. It gets a little tricky when you got 3 variables, 3 unknowns you're trying to solve for. And the other is the matrix method. Now, a lot of you, I'm sure, just plug it into your calculator and get an answer. I mean, quite frankly, I do that myself when I'm teaching some of the engineering classes, and you got multiple equations and multiple unknowns, whether it's in a mechanics class or a electrical class. Plug it in the calculator and get it out. This is the process that's actually done inside of your calculator. Same thing, I know somebody posted in one of the exam questions in the discussion, what's use the solver? It's doing the same process. So the process is this, you put each of these sets of equations into standard form, meaning you've got one variable, the second variable, the third variable, and your constants all over on the other side of the equal sign. You then take those in standard form and plug them into 2 matrices. So the first one, you notice, is my x1, my x2, my x3. So you look at my first equation, 3x1 plus 2x2 plus 4x3, you'll see 3, 2, 4, right? Those are the coefficients for those unknowns. So I do that, each of the 3 equations. My second matrix is a 1 by 3 in this case, or a vector that has my constants, my 5, my 17, my 11. So the process is this. You invert the coefficients from your variables, and then you multiply that value by your constants, and the 1 by 3, or the vector that you get at matrix or vector at the end, is your solution. So I have x1 is 0.846, 3.86 for x2, and minus 1.308 for x3. That's my solution. This works as long as the determinant is not 0, which we'll deal with in the assignment number 4. So there's the first one. Here's the second one. Now, the trick for the second one is, you notice again, these need to be in standard form. So the second equation has an x and a y, no z, so the z is a 0. The third equation has an x and a z, so the y is 0. You can see I have those zeros as placeholders. If you don't put those zeros in, right, your solution is going to be wrong in that particular case. X, Y, Z. My solution, right, x, y, z at the end. So x is 0.230, 0.128, and 0.102 is z. Now, I personally like to do this, set up the equations once, and then copy the pages. That's why I put them all on separate pages and suggested that you do the same. So when you get to this one, basically you've got to modify your page, which I think is easier if you cut and paste and then modify it afterwards. And actually I did this one, I did this the nicest of the 3 when I cut and pasted, because you notice that, right, the variables are x1, x2, x3, and instead of just putting an x at my answers, I put x1, x2, x3, x4, so you can see the actual solutions going along with it. Same process, now you've got a 4 by 4 and a 1 by 4 matrix. You're going to take your coefficients from your variables, you're going to invert it, multiply it by the constants, and voila, you'll have the answers. So there you go. There is the solution for problem number 2 from assignment number 3.